Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, on to lesson 2 of chapter 3. This is going to build on what we were doing in our last lesson, where we're identifying terms within the expressions for the explicit purpose of simplifying the numerical expressions and essentially finding an answer to the problems. Okay, so let's just get right into it. In today's lesson, you will continue to simplify expressions using the correct order of operations. You will also learn how to identify terms and expressions that are more complicated. All right, so I'm going to say don't draw these out. I didn't do that. It was a little bit complicated, and I'd rather not spend the time doing it with the more complicated expressions. We'll get a chance to do some diagrams with integer tiles in a little bit later problem within this lesson, but let's not do it for these. So basically what I want you to do is just copy them down and go through the order of operations to simplify each one of these numerical expressions, okay? So go ahead and pause to copy these down, and then if you choose to circle the terms and then simplify each term before adding them together, you may do that, or you can just use PEMDAS like you've used since probably 4th or 5th grade, okay? Come back when you're ready. Okay, I'm assuming you copied them down, you worked through, and you think you've got an answer for each one. So let's start with A. The priority here has to do with the exponent, correct? We do have parentheses, but inside the parentheses, you already have a simplified expression. It's just -2, so there's nothing more to do there. So we will go to the expression, which means we have to take -2 and repeatedly multiply it 3 times. -2 times -2 is +4, and then times -2 again gives us -8. So once we've taken care of that, then we can multiply that times the 4, which would give us -32. And now that we've only got addition from left to right, we can add -3 plus -32 plus 5 and get -35 plus 5 gives us a final answer of -30. So this expression simplifies down to -30. Here, this is going to be a little bit trickier, okay? So we do have some parentheses. Now, I might have done both of them at the same time. Since this is a completely separate term than this one, if I choose to do the exponent before doing this parentheses, it's not really going to affect anything, okay? So if I truly did the order of operations, I would say -2 plus 5 first and then say 4 times 3. But then I'm supposed to do exponents first, so I'd come over here to do that. Then I'd come back to the 4 times 3. Technically, I can do both in either order simultaneously, or I could have done this first, then done that, and they will not affect each other because they are separate terms, right? This is a separate term from that one, so it doesn't really matter if I did exponents before parentheses. Separate terms. Okay, now some of you might be asking, why is that -9 instead of +9? Because -3 squared would be -3 times -3, which would put us at +9. However, there's something to be aware of here. The parentheses that we had around this -2 meant that this -2 was repeatedly multiplied together 3 times. In this case, there's no parentheses attaching, or there's no parentheses around the -3. So this technically means, I'll write it down here, -1 times 3 squared. Anytime there's a negative sign attached to a number, it literally means -1 times that number. But when you're multiplying, exponents have the priority over the multiplication. So we like to say the exponent applies to what it touches, and it is only touching the 3 here. It's not touching the negative part. Where here, it was touching the parentheses, which meant we had to include the entire -2 in our exponent operation. Here, this literally means -1 times 3 times 3. -1 times 3 is -3, and -3 times 3 is -9. That's supposed to be a 3 there, okay? So this is something that's a source of great confusion. We just need to practice it and understand how the order of operations works and what -3 literally means. It literally means the opposite of 3, or -1 times 3. So this technically is the opposite of 3 squared, which is -9. So now when we add -9 to 4 times 3, we get -9 plus 12, which gives us a final answer of +3. So I'm anticipating quite a number of people made mistakes on these. Go ahead and fix your mistakes. These are the correct answers. Okay, so Katrina and Madeline were working on a problem on problem 312 when Madeline noticed these two expressions look almost the same, except one of them has 2 terms and the other one has 3 terms. Discuss Madeline's observation with your team. Explain which expression has 2 terms and which one has 3. Okay, so they're not asking us, are they asking us to simplify this? I don't think they are. They're just how many terms does each one have, okay? So let's go ahead and circle the terms. Remember, the terms are the parts that are being added together. And so that -3, that's just one term, right? That's -1 times 3. And this is 4 times -2 cubed. So this is what I like to term a complicated mess. There's a lot of multiplication going on in here. And technically, exponents are repeated multiplication. So this is really like 4 times -2 times -2 times -2. All of that makes one single term. And then this 5 is a single term, which means this has 3 terms. This is the one that has 2 terms. Here is our 1 term that's technically -1 times 3 times 3. And then this is a complicated mess that involves parentheses and multiplication. So this entire process right there is one big term where the sum of what's in the parentheses is being multiplied times the 4. So that all gets included as a single term. So this expression has 2 terms. All right. Let's copy this down. You are going to work to draw a diagram representing what this looks like. Now, it says you could use Cecil, the Cecil movement diagrams, or you could use the plus and minus tiles. I chose to use the plus and minus tiles because I think that's easier. I would recommend you do that because you're not going to be able to check to see if you got it right if you do the Cecil on the tightrope kind of a diagram with the arrows going to the left and to the right, okay? So if you just use the plus signs and the minus signs for your positive and negative integer tiles, then you'll be able to check to see if you've got the same thing as mine. So go ahead and copy this down, draw what you think the representation looks like, then simplify the expression and write it as a single number, and then circle the terms in here so you can see just how many terms there are in this within this expression. Okay? Pause and come back when you're ready. Okay, so you're going to see a combination. You're going to see my answer to C and to A all together. There we go. Okay, so that's the diagram, and here's the answer for C, where I've broken it up into 2 terms. Okay? So within the first term, you've got 3 groupings of 5 plus 2 times 4. So the 2 times 4 is the 2 groupings of 4 tiles each, and that's equal to 8, correct? And then you add to that 5, so this would be a 13, this would be a 13, and this would be a 13. So if we did the order of operations, we would say 8 plus 5 is 13, and now 3 times 13 is a total of 39. So there should be 39 pluses or positives in this particular term. In this term, you've got 2 times -3, so that's pretty straightforward. And now when you add them all together, what is 39 plus a -3? No, -6 should give you an answer of 33. Okay? Okay. All right, now for the most work that we've got here. This is probably the least amount of fun you're going to have in this lesson, but the next problem that we're going to do is the most amount of fun you've ever had in any lesson in your life, so I'm going to try and make it up to you, okay? So what you need to do here is for each of the following, visualize Cecil's movements or a group of positive and negative tiles. Then describe how you see the expression. How many terms do you see here? circle the terms, and then simplify the expression. Okay, so I did not show any of the work. Am I going to show any of this work here? I'm not going to show any of that work there. If you ever have a question about a problem and I don't show the work, once again, I've said it in previous lessons, but I'll say it again. Send me an email. Say, hey, problem number 15B, could you work that out for me? And I would be happy to work it out for you and send it to you, reply it to you in an email, okay? But it's going to be a 40-minute video if I work out every single one of these problems for you. So pause the video. When you come back, I will have circled all of these terms, and I will reveal what the answer is for the simplified expressions, okay? So go ahead and do the pausing. I'm going to pause right now so I can circle all these terms. All right, welcome back. Do your circle terms look like mine? Let's just go from each one. And in fact, I'm going to do this right now so we don't overcomplicate things. Starting with A, 3 times 8.63 plus 1. This is what I consider a complicated mess, so that's a multiplication problem. So that right there is one single term. So once you multiply them together, then you can add to the 1 to get 26.89. Notice here, we just used commutative property. We're still having to multiply 3 times 8.63 before we can add to the 1, but even the fact that the 1 is listed first, you're still adding these two numbers together, so you're going to get the exact same answer of 26.89. Here we've got some of the same numbers, but notice how they're grouped a little bit differently. Here we've got 3 terms. You got the 4 1/3 that gets added to the product of 2 and 3 2/5. Once you find out what that is, then you can add the 5 to that product to the 4 1/3, and you get 16 2/15. Here, we've got the parentheses around the 3 2/5 and the 5, so you have to add those together, and you'll get 8 2/5, which would double, which would give you something around 16, right? Because 8 times 2 is 16. A little bit more than 16 plus 4 1/3 gives you an answer that's in the 20s, and that's 21 2/15. Okay? Now, did you notice how I was kind of estimating what the answer would be before I actually showed what the answer was? That's a critical part of mathematical thinking. Think out loud. What is the problem telling us? What is your estimate if you were to round that off? What do you expect your answer to be close to? If I expected my answer to be somewhere in the low 20s, but I'd gotten 16 2/15, I know I would have made a mistake while solving the problem. So always estimate what you think your answer should be. If I come up here, 3 times 8 is 24, but that rounds up to almost 9, so your answer is probably going to be closer to 27 than it is to 24, right? So something around 26 or 27 plus 1 is going to get you something in the vicinity of 27 or 28, and that's what we got for the answer. Here we've got 3 terms. 4 plus -2 is 2, and that's going to be 15, so I think our answer's got to be 17, right? Yeah, so I did that one in my head exactly. What do we have here? Here we're going to have to add everything together before we multiply times 2, and since all of this is one big product, the quantity inside the parentheses times 2, what does that end up being? -1. 4 times 2 should be 8. There we go. And then these last 2 problems, we got 3 terms here. So 20, that's going to be like 40 or 50. That's going to be -15. So what does that end up being? -11 and 50, somewhere in the high 30s for our answer, or maybe low 40s. Yeah, low 40s, 42.6. And then here we've got 2 terms. There's a complicated mess. That's going to be around -30 or something. This is going to be 105 times 3.5. So that's going to be in the 300s. And then your -30. I still think our answer is somewhere going to be in the vicinity of -300. What do we get? No, not -300, +300. This was positive, that was negative, and we had way more positives than negatives. So yeah, +337.1. Okay. All right, this game is called Aim for 16. And there was generally when we play this game, what we do is we roll the die. We got 4 different die. You can actually do this at home, and I highly recommend you do this. This is a great game that you can play with your brothers and sisters. If you got any brothers or sisters that had me in previous years, they've seen this game before, or in your parents, you can play with them as well. And it's basically just try and come closest to 16 as you can. So here are the rules. You got 4 numbers. These numbers are going to be either 1, 2, 3, 4, 5, or 6 because we're using dice to create the numbers, okay? And you're allowed to use any operation symbols and any parentheses. But here's the rule. You have to use each one of these numbers, and you can only use them once. And your goal is to get them as close as you can to the number 16. Now, it does say here, a number cube lands on 5. You can either use 5 or -5 for your expression. The -5 is kind of like if you were subtracting a 5. So it kind of is like I could call that a -4 and this a +4 because if I said 4 minus 4, then that becomes a -4, right? So let's copy these down. And I believe, I didn't think this was true at the very beginning, but I think there's something magical with this game where there's always a combination where you can get 16. And the reason why I think that is because I had a student a few years ago who always got 16, no matter what. She was a very strong math student, mathematical thinker. And while the rest of us were getting like 18s and 15s and 17s, she always figured out a way to get 16. It was remarkable. So I think there's almost, if not always, a way to get 16 out of these numbers, okay? So copy those 4 numbers down, 4, 16, 4, and 1. Actually, you know what I'm going to do here? I'm going to create a little game board for us. I'm going to do it right here. Hey, stop it. Dude, do it. No. Okay, sorry. Got to make some adjustments here. Hey. You little... Okay, I'm going to pause. This is making me upset. I don't want to swear on my video, so I have to pause this. Oh my gosh. I dropped a few bombs there, but everything is okay now. Don't you worry. And when I say bombs, I don't mean anything bad. So just ignore I said that. All right, so 4, 6, 4, and 1. How can I turn that into the number 16? I've got it. I am so happy with myself. I'm going to put 4 times 4 inside parentheses. That's 16, right? Which means I need to get this to be able to be equal to 1 or something. So I'm going to say times 1 to the 6th power. And that, my friends, is equal to 16. So 4 times 4 is 16. And then 1 to the 6th power literally means 1 times 1 times 1 times 1 times 1 times 1, which is 1. And that's how you get 16. See how this game works? What fun. Okay, so I'm going to clear all that off. And let's do it again. This time, we're going to have the number 6, 3, 6, and 6. 3 6s? That's horrible. Okay, but we got to work with what we got. 6, 3, 6, and 6. All right, I'm pausing. You go ahead and pause and see if you can figure out. Now, I'm telling you right now, you and I could both get to 16 and have a different way of getting there. So it's not like you have to do it the same way that I do it, okay? So when we come back, I will have 16. I hope you have 16. Otherwise, I'm the winner. Did you make it? I have to admit, I did not find 16. But I found 17. And this is how I have 17. If I take 6 times 3, put that in parentheses. I'm not sure that really, yes, I need to have, no, I'm not sure if I need to have parentheses there. And then I'm going to subtract away 6 divided by 6. So this ends up being 18 minus 1 is equal to 17. If you figured out a way to get 16, please send me an email. I would love to see it. Okay. Let's do one more. Let's clear the slate. You move out of there. Let's go. Stop it. Let's take this number, this number, this number, and this number, and write them down. We've got 4, 3, 1, and 2. All right. Good luck. First one to 16 wins. All right. I found it. Here's what we need to do. We need to take 4 and raise it to the second power. That literally means 4 times 4, so that is 16. How am I going to take the 3 and the 1 and make that equal to 1? Well, we did it once before. If we take 1 to the third power, that is 1 times 1 times 1, which is 1, and 16 times 1 is equal to 16. Okay, so how we order the numbers, what operations we use, whether or not we choose to use exponent operations or parentheses, can affect how big of an expression, how high the value can be after we simplify it, or how low it is. And we can also, a lot of times manipulate those numbers and operations to get a specific target. Okay, so go ahead and play this game. If you've got a Yahtzee at home, you've got lots of dice. If your parents like to play liar's dice when they have friends over and they do lots of gambling, they probably have at least a dozen dice for you to play with. Just don't lose them, because that's a real bummer when someone loses all the dice for liar's dice games. Okay, so good luck with everything. Good luck on your homework, and have fun playing this game. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed,